Hi, welcome back to my channel pibyme Maths. This is by WST02. Here we are solving October-November 2024 Statistics 2 paper. In the previous video, we have covered question number 1, 2, 3 and 4. Let's look at question number 5. The continuous random variable x has a PDF function given by this. The cumulative distribution of x is capital F of x. Show that capital F of x is this for this interval. So you need to take the particular function and integrate it. Always remember, from small f of x to capital F of x, you have to integrate it. From capital F of x to small f of x, you differentiate it. Okay? So when we integrate this, f of x is integral. You can keep 1 over 4 outside. Integral 3 minus x dx. That's going to be 1 over 4 3x minus x square over 2 plus c. And then we need to find the value of c. For this interval, you can write f of 1 is 0. If you are using the first limit, f of 1 is 0. If you are using the last limit, it's 1. You cannot use this for this function actually. You need to either use f of 1 is 0 or f of 2. You don't know the value of f of 2. You cannot use that. So we need to use that condition to find the value of c. So you put f of 1 is 0. So you will get 0 is 1 over 4 3 minus half plus c. So 1 over 4 times 3 minus half is 6 minus 1 5 over. That's 5 over 8 goes to the other side minus 5 over 8. So you can write therefore f of x is equal to 1 over 4 times 3x minus x square by 2 minus 5 over 8 for 1 is less than or equal to x less than or equal to 2. It's just a 2-mark question. Sub in the value of c here, you got f of x already. Let's look at part B. Find f of x for all values of x. Now we need to find the complete f of x. It's a 5-mark question. Okay. So let me put the PDF function here. Okay. I have put the PDF function here. We got f of x for the first one already. Now take the second one. F of x is equal to integral 1 over 4 dx, which is x over 4 plus c. And we need to find c actually. So you need a condition. You either need the condition f of 2 is equal to some value or f of 3 is equal to some value. These are all the two limits here, right? But from the previous function, we know f of x is equal to 1 over 4 3x minus x square over 2 minus 5 over 8 for 1 is less than or equal to x less than or equal to 2. Sub in 2 here. So you will get the value of f of 2, which is 1 over 4 times 3 2s are 6 minus 4 over 2 minus 5 over 8, which is basically 1 minus 5 over 8 is 3 over 8. So we are going to use this condition f of 2 is equal to 3 over 8 in here to find the value of c. 3 over 8 is equal to 2 over 4 plus c. So c is going to be 3 over 8 minus 1 over 2. So we got minus 1 over 8. C is equal to minus 1 over 8. Therefore f of x is x over 4 minus 1 over 8. That's for this one. We got these two. Integrate the next one now. Okay, integrate the third one now. So f of x is 1 over 4 integral x minus 2 dx. So f of x is going to be 1 over 4 x square over 2 minus 2x plus c. I'm going to sub in the condition f of 4 is 1. So 1 is 1 over 4 times 4 square over 2 minus 2 times 4 plus c. You get the value of c. C is basically 1. Okay, wait, let me calculate this whole thing first. 1 over 4 times 4 square 16 over 2 minus, hey, that's 0. So C is basically 1, right? So f of x is equal to 1 over 4 x square over 2 minus 2x plus 1. We got the f of x for all three functions. Now that's not enough. We need to write f of x by combining all three. F of x is equal to, the first function corresponding to this is what we calculated in part A here. This one. 1 over 4 3x minus x square by 2. 1 over 4 3x minus x square over 2 minus 5 over 8. Write the limits same as the one given in PDF. For the second one we calculated here, this one, x over 4 minus 1 over 8. X over 4 minus 1 over 8, the limit is same as the PDF. Third one we calculated here, 1 over 4 x square over 2 minus 2x plus 1, the limit is this. And then you need to write 0 here. 0 when x is less than 1. 1 when x is greater than 4. That's how you write capital F of x. It's a 5-mark question. Part C now. P of 1.2 is less than x is less than 3. You can write it this way. P of x is less than 3.1 minus P of x is less than 1.2. In continuous random variable, less than 3.1 is same as less than or equal to. So that's cumulative. This is cumulative. F of 3.1 minus F of 1.2. So take the cumulative distribution capital F of x. I'm going to put the capital F of x here. For 3.1, you need to use this. This function replace x by 3.1. So 1 over 4, 3.1 square by 2 minus 2 times 3.1 plus 1 minus. For 1.2, 1.2 is in this limit. So you need to use this actually. Replace x by 1.2. 1 over 4 times 3 times 1.2 minus 1.2 square over 2 minus 5 over 8. And then calculate this, you will get the value. You have to be very careful when you calculate this. It's 1 over 4. 1 over 4 times 3.1 square by 2 minus 3.1 square over 2 minus 2 times 3.1 close the bracket plus c plus 1 minus, okay, this whole thing should be inside the bracket. So the minus is a common minus. That's very important. So I'm gonna put an open bracket here, or let me just calculate this. 521 over 800 minus, okay, now 1 over 4 times 3 times 1.2 minus 1.2 square over 2 close the bracket minus 5 over 8. That's 19 over 200. 800 is 89 over 160 is the final answer. That's all. You have to be very careful when you plug this in your calculator. That's when you are gonna make mistake. So you need to be double careful here. So that's all. Anyway, let's move on to question number 6 now. This is apparently from sampling distribution. Two boxes A and B each contain a large number of coins. In box A, there are 1 peso coins, 2 p coins. Okay. The ratio of 1 peso coins and 2 peso coins is 1:3. That means probability of 1p is 1 over 3. Sorry, 1 over 4. The total ratio is 4, right? 2p is 3 over 4. In box B, there are 2p and 5p coins. The ratio is 1 over 4. So 2p is 1 over 5. The total ratio is 5. 5p is 4 over 5, right? One coin is randomly selected from box A, and 2 coins, we are collecting 1 coin, we are taking 1 coin from here, 2 coins from box B. The random variable t represents the total values of these 3 coins selected. Find the sampling distribution of t. So what would be the total value if you take all these combinations? 1 coin from A, 2 coins from B. Okay, we are taking 1 coin from A, so it can be 1p, and then 2 from B. It can be 2p, 2p, or 2p, 5p, or 5p, 2p, right? These are all the possible combinations. And then from A you can take 2p also, and then write the same combinations. We are taking 2 coins from B. It can be both 2p, 2p coins, or 1 2p, 1 5p, first one 5p, second one 2p. There is one more actually, both 5p, 5p. These are all the possible combinations, right? But the question says t represents the total values of these 3 coins. So when you add here, you're gonna get 5, 6, 9, 8, 8 here again, 9 again, that's 11, that's 12. So you put them in ascending order. Totals t is equal to, you can put them in the set bracket in the ascending order. You don't need to write it in ascending order, but make sure you don't miss out any values. 5, 6, don't write the same values twice. 11, 12. These are all the values t can take. That's all. That's what part A. Not just the values. It's a 7-mark question. We need to find the distribution. That means we need to find the probability corresponding to each value now. Okay. When p of t is equal to 5, t is equal to 5 comes from this combination, right? For the first one, it's 1p. 1p, the probability is 1 over 4 times. The second one, 2p, 2p. 2p comes from box B. So 1 over 5, 1 over 5, get this probability. That's 25, 1 over 100. If p of t is equal to 6, okay, we are done with this. Now 6. From box A, we are taking 2p coin. So the probability is 3 over 4 times. Box B, we are taking 2p, 2p. So 1 over 5, 1 over 5. You're gonna get 3 over 100 now. The same way, you need to find the probability of all these numbers, one by one. That's why this question got 7 marks. So we are done with this 6 now. Let's look at 8 now. Okay, I copied the whole thing here. P of t is equal to 8. The first one is 1p. There are 2 8s, right? The 1p coin from box A, so the probability is 1 over 4 times. From box B, it's 2p, 5p. Can be in any order. So from box B, 2p is 1 over 5, 5p is 2 over 5. There are 2 combinations, so multiply by 2. That's gonna be 8 over 100. Simplify it later, because when you write the distribution, the total should be 1, right? So just keep it as it is now. So we are done with 8 also. Now for 9. P of t is equal to 9. The first one is 2p from box A, which is the corresponding probability is 3 over 4, and 5p, 2p from box B. So this probability and this probability, 1 over 5, 4 over 5, there are 2 similar combinations times 2. That's basically 4 3s are 12, 24 over 100. 24 over 100. So we are done with this also. Now for 11, P of t is equal to 11. 1p from first one, first box, this is box A, this is box B. 5p from box B. 4 over 5 times 4 over 5 is going to be 16 over 100. For probability of t is equal to 12, the next one, we are done with this, the last one now. 2p from box A, so the corresponding probability is 3 over 4 times 5p from box B, which is 4 over 5, 4 over 5, which is 3 4s are 12 times 4, 48 over 100. Now we need to draw the probability distribution table now. So I'm gonna draw a probability distribution table now. We write P of capital T is equal to small t. So what are the values t takes? 5, 6, these values 5, 6, 8, okay, 5, 6, 8, 9, 11, 12. 5, 6, 8, 9, 11, 12. Write the corresponding probabilities. 48 over 100, 16 over 100, 24 over 100, 8 over 100, and then 5 and 6. 5 and 6 we calculated here. 1 over 100, 3 over 100. 1 over 100, 3 over 100. Now the main thing is, if you add all the probabilities, you should get 1. So make sure you verify that. If you add everything, you're going to get 48 plus 40 is 88, 89, 92, 100 over 100 is 1. That's all. We got the distribution already. It's a 7-mark question. Part B. A random variable m represents the median of the values of 3 coins selected. That means, let's say the 3 coins selected are 1p, 5p, 2p. You first write them in ascending order and then find the median. That's how we find the median, right? So median m is equal to 2. So we need to do that for every combinations actually. So I'm going to put all the combinations here and then the probability distribution we got from the previous part. So here we have all the combinations. Let me write the median of each combination. Here the middle number is 2. Here also 2. Here also 2. 2. When you write them in ascending order, it's going to be 1, 2, 5. So 2 again. 2, 2, 5. 2 again. 1, 5, 5, 5. 2, 5, 5, 5. So the median values are m is equal to 2 or m is equal to 5, right? Let's find m is equal to 5. That's a lot easier, right? M is equal to 5 is this combination. That's 10, 11. The corresponding probability is 16 over 100 plus. Here the combination is 10, 12. The corresponding probability is 48 over 100. You will get 64 over 100. So if this is probability of m is equal to 5, you can find m is equal to 2 as 1 minus this, which is 36 over 100, and you can write the probability distribution. But since it's a 4-mark question, I would rather write how we got m is equal to 2. M is equal to 2 is by taking this combination. Is there any other combination with total 5? No. So the probability is 1 over 100 plus. So we are done with this, this and this, right? Okay. And then here the probability of total is 6. So I need to take the corresponding probability 3 over 100 plus. We are done with this also. And then here the total is 8. This also 8. So when you add both the probabilities, that's what given here, right? For 8. Don't write it twice because we added these two and you have written it as 8 over 100 here. So 8 over 100 plus. So we are done with this and this. And these two probabilities of 9 and 9. So adding this, we got this probability 24 over 100. So when you add 24, 32, 35, 36 over 100. Now just draw the probability distribution table now. So draw a table. small m p of capital M is equal to small m. There are only two values, 2 and 5. The corresponding probabilities are 36 over 100, 64 over 100. Definitely the total is 1. That's all. It's a 4-mark question. Question number 7. That's the last question from this paper. We have a probability density function of a continuous random variable x, and the figure is also given. As you can see, from 0 to 4, it's a line y is equal to ax. From 4 to 8, it's bx plus c. Okay. Now, let's look at part A of the question. Figure 1 shows the graph of the PDF. The graph consists of two straight line segments of equal length joined at 4. They are saying these two lengths are equal. Okay. And then show that A is equal to 1 over 16. We know the area below the curve is 1, right? How do we find the area? This point, when you sub in 4 into this function, we can first write f of 4 is equal to 4a. Therefore, we can find the area of the triangle half times base. Base is 8, height is 4a, because this is f of 4 is 4a, right? So half base times 4a is equal to 1. So a is equal to 1 over 16. Just a 1-mark question. Part B now. Hence find the value of B and the value of C. Part B now. Find the value of B and C. Okay, let's look at the figure now. We know A is here, 4 is here. And when we sub in, we got 4a as the function value. We know a is 1 over 16 from the previous part. So 4a is 1 over 4. So this is 1 over 4, right? In the function, I'm going to sub in 4 into the function. So f of 4 is equal to this, right? 1 over 4, right? So I'm going to use f of 4 is equal to 1 over 4 into the second function, into this. Okay, let me put the function key. Okay, I have put the function and figure here. So we know f of 4 is 1 over 4, right? So even you put 4 here, you should get 1 over 4. Even you put 4 here, because it's a continuous random variable. So f of 4 is 1 over 4. I'm going to replace x by 4 here, f of x by 1 over 4. So I will get 1 over 4 is equal to 4b plus c, right? And then this is 8 comma 0. That means in the function, if you replace 8, f of 8 is going to be 0. So 0 is equal to 8b plus c. That's equation 2. So equation 2 minus 1, you're going to get 8, cc will be cancelled, 8b minus 4b. 4b is equal to 0 minus 1 over 4. So b is minus 1 over 16. We got the value of b already. So let me remove this figure. Now sub in b into any one of the equation. I'm going to sub in into the second equation. Minus 8 over 16 plus c is 0. C is going to be 1 over 2. So this is I, this is double I. That's all. Okay, part C. Using algebraic integration, show that variance of x is this. So you need to find E of x and E of x square. To find E of x, you can use integral f of x dx. That's what we usually do, right? You don't need to do that, because look at the curve. The curve is symmetrical about the middle line, right? Because these two are same. It's isosceles triangle, so it's symmetrical about the middle line. So E of x is by symmetry. E of x is equal to 4. That saves some time, because otherwise we need to integrate the whole function. But E of x square, no escape. We have to do integral x square f of x dx. Since x square is a piecewise defined function, you have to put it as 0 to 4 x squared times f of x is ax plus 4 to 8 x square times bx plus c dx. We calculate this, e of x minus e of x whole square will give you variance of x. So when we integrate this, it's going to be, we know the value of a is 1 over 16. 1 over 16 x cube becomes x power 4 over 4, 0 to 4, plus, when you open the bracket, you are going to get bx cube plus cx square. So b x power 4 by 4 plus c x power 3 by 3, 4 to 8. We have to carefully simplify this. Here when you sub in lower limit, it's 0, so you can forget about it. When you sub in upper limit, 4 power 4 divided by 4, you see, 1 over 16 times 4 power 4 over 4 is just 4 cube. That's just the whole thing becomes 4. Okay, here let's calculate when we sub in the upper limit. So I'm going to do it carefully. Minus 1 over 16 minus 1 over 16 times 8 power 4 divided by 4, x power 4 by 4, plus 1 over 2 times x cube over 3, okay, plus 64 over 3 when you sub in the upper limit, minus, I'm going to sub in the lower limit, so I bring the cursor here in the place of x, I change it to 4, change it to 4, 20 over 3, that's basically 4 plus 44 over 3. 12 plus 44 is 56 over 3. That's e of x square. So variance of x is e of x square minus e of x whole square, which is 16. 3 times 16 is 30, 48. So it's going to be 8 over 3. That's all. It's a 6-mark question. So let's look at part D now. Find to 2 decimal place the lower quartile and the upper quartile. Okay. You see, these two lines are same in length, and this is going to be, if they ask you to find median, it's going to be 4 actually. Okay. So the Q3 is definitely this side, right? Between 0 to somewhere here. The Q1, lower quartile. So we are going to take this function. If you know capital F of x, you are going to use this to find Q1 or this to find Q3, right? 0.75. So we don't know capital F of x. So we take small f of x. When you integrate it from 0 to Q1, you will get 0.25. So it's ax square over 2 is 0.25. A over 2 is, a is 1 over 16, so 1 over 32. Sub in the upper limit minus lower limit is 0.25. Make Q1 as a subject. So 32 times 0.25, which is 8. So Q1 is square root of 8. Okay, now listen to me carefully. Q1 is square root of 8 here. So therefore, due to symmetry, Q3 will be here, which is, this length is going to be square root of 8. This will be 8 minus square root of 8. So you can write, therefore, by symmetry, Q3 is 8 minus square root of 8. That's all. So 3-mark question. Now let's move on to part E. Again, I put the graph and the function here. A statistician claimed that this, okay, when you put mu both side, add mu both sides, it's going to be mu minus sigma is less than x is less than mu plus sigma is greater than 0.5. This is what he claims. Okay, show that his claim is correct. Okay, we know mu is same as e of x, which is 4. Sigma is square root of variance of x, which is, we calculated variance of x here, right? 8 over 3. So square root of 8 over 3. So you can write this as P of 4 minus square root of 8 over 3 is less than x is less than 4 plus square root of 8 over 3. Don't write it's greater than 0.5 because that's what we need to verify first, whether it's correct or not. Okay. We know the Q1 is here. So definitely this area is 0.25, right? Q3 is here. So definitely the area on the left hand side is going to be 0.75. So when you subtract 0.25, the area in the middle between Q1 and Q2 is going to be 0.5, right? So what I'm going to write, P of Q1 is less than x is less than Q3 is equal to 0.5, or the Q1 is square root of 8. Square root of 8 is 2.83. P of 2.83 dot 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 is less than x is less than 8 Q3. 8 minus this, which is 5.17. The area between these two values are 0.5, right? Now we are talking about the area between these two, 4 minus square root of 8 over 3 and 4 plus square root of 8 over 3. We need to check where these values lies, on the left hand side or right hand side. Okay, let's find the value. 4 minus square root of 8 over 3 is 2.36. So you can write P of 4 minus square root of 8 over 3 is less than x is less than 4 plus square root of 8 over 3 is equal to P of, this value is 2.36 dot 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 is less than x is less than 4 plus, that's actually 5.63. You need to understand what's happening here. Now you see, from the figure we know the area between square root of 8 to this area is 0.5, right? Now we are taking 2 points, 2.63 which is smaller than this, so the point will be here, 2.36, right? And then 5.63 which is bigger than this, it's here. So definitely when you find the area, it should be more than 0.5, right? So you need to write 4 minus, you can write mu minus sigma, and mu plus sigma lies outside of Q3, Q1 and Q3. Therefore, statistician's claim is correct, because he says the area is more than 0.5. That's correct. That's all.